Hi everyone. So welcome to our talk, and today we'll be talking for the next 35 to 40 minutes on flow in the reactive world. So before I jump into the slide itself and talking about flow, let me introduce myself. So I am a Google Dev expert for Android. I am a speaker, blogger, and mentor. I am also an open source contributor, and I am also one of the core contributors for Government of India's contact tracing app RxJava, and currently working as a senior Android engineer at 1MG. So with me is my co-speaker Himanshu, and I would like to him to come and introduce himself.
Hello everyone. So I'm Himanshu. I'm also a Google Dev expert for Android. I have been into speaking for quite long. I've been blogging as well. Apart from all of these, I like to build open source libraries more or less, and I work as a senior Android engineer at Rumi. So even before starting anything today, let's first understand what the agenda is for the talk. So the agenda, what we are going to discuss here is understanding the core problem which we have while designing an Android app, or let's say writing an Android app. So first we'll discuss the problem which we have in our hands. Second, how coroutines and flow actually solves it for us. So this might be a very new topic for a lot of people, but we are going to explain you guys coroutines as a basic thing, and then we are going to discuss how we can use flow alongside coroutines. Then we'll also understand an internal view of how Kotlin Flow is actually designed. We are also going to discuss on a very generic level how coroutine is also designed, but this topic is actually designed for Kotlin Flow. So we are going to focus more on that part. And at last, let's say that if you're using any other property, let's say RxJava, or you're even using the core threading model, we are also going to help you and understand how we can actually migrate to Kotlin Flow alongside using coroutines and many more aspects to it. So this is going to be more of a practical learning, just rather than just going through a talk. So over to Niharika now.
Thank you, Himanshu. Before I deep dive into the aspects we mentioned in the agenda itself, let's start with a very basic concept, or I would say kind of style of programming and the basis on which we decide to opt any framework or library or any component. So we've always heard this synchronous and asynchronous kind of execution, and I think most of us are familiar with the term itself and why this style of programming matters in the world of technology or software. So in simple words, synchronous means connected or dependent in some way. We wait for one task to finish before moving on to another task. So it's like going line by line and blocking the next operation until it completes. Here we can imagine executing one thing at a time. Let's have a look at a very basic example, a kind of real world example. We all do have a login screen in our app, and with any username and password, we will be doing the login. Now, maybe you need a key like user ID to do another operation, like fetch user details for a particular user. Now your execution will happen line by line. Seeing this looks super simplified code. We don't have to worry about our application being in another state when a response from a server is received. But our screen is blocked and being a user, even I won't be happy if I see my screen frozen or just loading something and I can't do anything with the app itself. Now, as many if we have many synchronous calls on our screen, it appears like a long response time, and UI is blocked until the resource responds. So this is a kind of bad for our application. So what we needed here was continuing with other tasks till the time that particular task gets completed, and it may just notify us when it completes to again focus on the next operation. Also imagine your device with a low network. It would be like a laggy application then. So if I have to summarize the drawbacks of this approach, as we discussed in the previous slides as well, if there are a lot of time-consuming lines of code, your application will become much slower to respond. I may define this as a responsiveness aspect of any application. And if I talk about performance, so performance is something which we all care about. It has been seen that while executing a request, around 70 or 80% of time gets wasted while waiting for the dependent tasks. So that is again bad in terms of experience as well. And if you are doing everything on main thread itself, and as there is no way to change threads, then you may have seen the network on main thread exception also, or app not responding to this kind of stuff. So it shouldn't happen, right? So to utilize the resources as much as we can and make our app responsive, even when some task is in progress and other things can be done in parallel, like an asynchronous style of programming, that kind of approach was introduced. It's like executing multiple things at a time. Again, in simple words, we are doing something in the background, like downloading heavy files or uploading some prescriptions, etc. Now, if I talk about specifically about the Android world, we have some options with us to adopt this kind of programming approach. And if we have to take care that if once a task is done, we may have to communicate to our main thread or view for other operations as well as while deciding those options. So one would be the traditional approach. We have like the threads itself. I have seen them getting used in all sort of instances. However, they are limited as Android doesn't really allow UI updates on the background thread. You may have alternatives with it, but again, more work. Also, if there are many tasks to execute, one thread per task can pose memory exhaustion and reduce performance. So it's just like we mostly can use it effectively for one-shot operations again. And if we check this programmatically, we'll find much overhead in terms of size and the context switching, etc. Then, of course, we have RxJava. In the last few years, reactive programming has taken some momentum, not only for Java, but for other platforms as well. So the whole concept revolves around observer pattern. We can manipulate threads easily using observe on, subscribe on. There are different operators like merge, zip, map, flip, flat map, filters for controlling the data streams. And also there are some callbacks for making the completion or some error in between the event flow. But yes, we have to manually take care of cleaning up any resources which we acquired and hell of callbacks here again. And also we need to have a good learning curve to understand all these subscribers, observer pattern in depth. Then this async task, everyone's favorite. I am just kidding. This is deprecated as well. The learning curve was pretty much easy with it. Adding our code in the background is all it takes to transfer a long calculation to another thread. But and the other methods allow us to handle a lot of simple use cases. But again, handling the configuration changes, multi-threading, parallel execution, and the risk of memory leaks for the class having async tasks is there. So if you haven't read about till now that why am I talking about this configuration changes or memory leaks, I would say please have a look for the set advantages and the reason for the deprecation as well. Now, this one is my favorite, and I think most of us right now. It's Kotlin coroutines. We'll discuss it in more details in the upcoming slide. So these are some of the options, not just the only options. Like we have another options like handlers, event bus, etc. But even with handlers, they again deal with threads and have some kind of limitations. So let's deep dive into coroutines. The concept is not new with Android. You may find it in many other languages like Python, Go, etc. But now the question arises, how are coroutines helping us in a synchronous approach? Why are we following it? Why are we using it? And what exactly is the advantage we have by using it? So as per the definition, coroutines are lightweight threads. By lightweight, it means that creating coroutines doesn't allocate new threads. Instead, they use the predefined thread pools and kind of smart scheduling for the purpose of which tasks to execute next and which tasks to take up later. So, and coroutines internally uses thread pools behind the scenes. Like thread, they can execute tasks concurrently. They are not bound to bound to a single thread, and instead the Kotlin coroutine, Kotlin runtime, if we have, which actually determines when and where coroutines run. So they are cooperative as we have this in the name itself. Means this cooperative. So this signifies if the coroutines will be blocked or like doing some heavy tasks, then they may be suspended. They can suspend its execution, and the runtime, Kotlin runtime finds another coroutine to execute in its place. So as a result, they can achieve a higher level of concurrency, because a single thread right now can run many coroutines with just more memory usage, and I would say that is in just bytes. If I compare to thread, if I compare to thread, they are like, I think, using 1 MB kind of stack size for them. And also the context switching is kind of now replaced by suspension, and OS doesn't need to interfere for any kind of scheduling part among coroutines. Now, above all, were like some convincing points for how coroutines are better than other approaches. Let me add some more reasons to use it. So this is again the same example we saw when we discussed the synchronous approach. Now, but what if the writing is seen as easier as it looks in the synchronous programming approach, like writing everything sequentially, but leverage the asynchronous way behind, easy to understand and relatable, and any one of us can easily interpret what is getting done here, not looking at different classes or like how the callbacks are coming up and what is the actual flow. And if I have to pick this kind of solution, I would definitely go for it. And now you can see what all minimal changes we have to make to use it like this way. So both the functions we are calling, we will be adding, we have to use this suspend modifier, and we need to launch this particular block in a scope like this. That's it. So not many changes, and we have preserved our synchronous but yet sequential approach here. So we saw suspend modifier getting added. What is that? So as when we talked about the definition for coroutines, we mentioned that they can suspend themselves instead of staying blocked. So suspend functions helps us out in this process. It's a function which can be paused and resumed at a later time, like we are ready with the result for that particular task. And as you see, they have the similar syntax as we have for the regular functions, not any fancy work here. And you just need to have this suspend keyword added. So this tells the compiler that this function needs to be executed inside a coroutine. They hold the property that says a suspend suspend function can only be called from another suspend function or within a coroutines itself. We can't call them from anywhere. Then we have something like coroutine scope, like we saw this launch in the example above. These are just an extension of these coroutine scopes. So scopes are just nothing but the restrictions, I would say, within which the coroutines are being executed. So basically, they help us to predict the life cycle of the coroutines. Actually, it's like when the scope is destroyed, all the running jobs inside the scope, which they will be cancelled or destroyed. It's like if someone has used RxJava, you may recall or compare it with a subscription there. We may use different scopes like global, view model scope, life cycle scope as well. But we should avoid global scopes as much as we can. If we understand the definition itself, you can relate as it is something related to life cycle of that particular coroutine. So this will introduce a concept here named structured concurrency. So devs don't really have to care about kind of leaking jobs for their coroutines flow, etc. Now, we understand the basic functionality, and every time we are dealing with coroutines, we'll come across these keywords and terms. But now, above all, did you ever think that how exactly is the magic happening? We just added this suspend and launch. How are the things working behind the hood? How the compiler is working under the hood? So now the magic revolves around this only reason, and that is you are suspended. Let's analyze this through my favorite login example, our favorite login example. So we had this login and fetch your user details methods now having a suspend keyword with them. And if you take a closer look, this getting, if you see, I'm getting a user ID, and then through that, after getting the user ID, I am just using it in another task. So this is all like what we are handling through callback. We were handling through callbacks, if you remember, in RxJava, in any other case. So let's see now what happens exactly. So so the Kotlin compiler will take suspend function and convert them to an optimized version of callbacks, and the compiler itself is now writing this hell of callbacks. Internally, these are just callbacks, and these are getting written by the compiler itself for us. When this computation we are doing can suspend, so now we are free from this. In the internal code, you may find this method getting replaced with having this continuation type added as a parameter. This is nothing but just again a callback. So coroutines call these callbacks with a fancy name, that is continuation. It's just a generic callback interface with some extra information added. If anyone remembers the finite state machine, like I said, if anyone remembers, I don't remember exactly before I dive into it. So basically, it will be representing the generated state machine of any of that suspend function, like what is a state now or later. Like when I initialize it, that is a state 0. Then if it gets suspended, then it goes to another state. And if I have to resume it, it goes to another state like state 2. Then if I have to finish, it will be going to state 3. So there is a state maintained there. And this goes on for every method we have with suspend keyword, and we call all this as a continuation passing style. So this continuation callbacks are doing whatever happening under the hood. So these are just callbacks. Now, if we look closely at this continuation interface, it contains two things. First is the coroutine context, which holds as context is always about some information itself. It holds the information, anything about the coroutine, like when it needs to run, any state or any errors. Then there is a function named resume with, which resumes the execution of a suspend function at the call site. It takes a parameter, and that could be either the value of any computation that causes the suspension, or it could be any exception. I would say, in other words, this param holds a value that can be passed back, either a successful response or a failed result. So the compiler is replacing the suspend modifier with the extra parameter completion of type continuation in the function signature, which basically it is using for the communication and the result of suspend function to the coroutines that called it basically. From Kotlin 1.3 onwards, you can also use this extension functions resume and with a parameter, and this resume with exception. These are nothing, just specialized versions of the resume with, which we discussed in the previous slide. Yeah. So this resume basically resumes the exception of the corresponding coroutine. We have this passing value as a return value of the last suspension point, and this another function. This resumes the execution of the corresponding coroutine with the exception which is getting rethrown right after the last suspension point, as its name also signifies that it holds some exception. So now we can very well relate this with callback style of programming, where you have some methods like on success and on failure. So nothing is magic. Everything is done the same way, but now the compiler is handling it much more efficiently, and we have less boilerplate code, of course. Now again, let me brief the benefits we got by using coroutines. Lightweight, no OS scheduling, no context switching overhead, as it is now handled using suspend keyword, less less boilerplate code, and of course the ease of understanding through a traditional way of writing code that is sequential, but with the advantage of running the code asynchronously. And I can say this as clear, non-blocking, and a linear code, what we got. Now, I have mostly heard this comparison for coroutines versus RxJava. I would say it's a partial information, which we always consider while working on these. As we saw in the examples above using suspend keyword, these are just one-shot operations. Like if anyone has used Rx, you have seen this single completable or maybe calls. So this is just, you can compare it with that. We are just having a simple network call, one-shot operations like those kind of calls. Now let me give you a scenario. Let's say you have a stream of user clicks, a stream of location updates, our application which is listening, or a stream of network updates we right now have subscribed to. So for these kind of operations, we can't just work with coroutines or suspend functions. In Rx, if you remember, we have observables and flowables for this kind of work. So what we can do here. So one important thing I would like to highlight here is coroutines is just a scheduler part of Rx as well. And also, as whenever they are launched using this launch or any other function to start a coroutines are hot, and even hot is the reason they are not just a replacement for the reactive streams itself. Now, coroutines can't alone handle this streaming of operations. There was a need of something else here, and that something is how Flow comes into the picture. And if anyone has to really compare with Rx, I would say something like this, that both coroutines and Flow with their single shot and multi-shot operations and reactive stream handling itself actually does the whole work of Rx. But don't get misled by like this, now we need to learn how to use both. I would say that's pretty much easier. And if you have to compare the benefits it provides, and of course the benchmark, which I saw in a summit, I guess, like there was a benchmark for an app named Scrabble, where Rx methods and operators took twice the time for the work that can be done by Kotlin coroutines and Flow. So lesser time, better performance, lesser code, and ease of understanding as well. So there are many reasons to adopt it here. Again, to summarize the benefits, Kotlin provides null safety in the streams, which basically means we can't send null values in the stream. It's also there in RxJava as well. And of course, you can use Flow with any other reactive stream libraries. We have very easy to understand APIs to convert Flow to any other reactive streams. We may cover some conversion today as well. Then we have some amazing operators like we had with RxJava. We don't need to worry about that. And even you don't really need some of the operators now, as some magic is already getting done through the suspend and coroutines itself. But the most frequently used like map, filter, etc. These are there. And also there's only just one single operator for both asynchronous and synchronous approaches. So we don't need to remember more operators to work with. So again, life is easy. And while using Flow, you don't need to worry about the back pressure handling. So the back pressure is something when the rate at which the producer is emitting values is more than a consumer can consume at that time. For that, now no special operator or code needs to be written. This is already handled internally, and of course using the suspend magic. You may read about buffer operator also when you deep dive more, and also the latest operator to get the latest value only during the consumption. Also, flows are just similar like a list or collection, but flows are cold, which means that they won't produce values until someone has subscribed to consume those values. Even all the flow operators are also called. You may get to know more about the terminal operators we may use for collecting these values in the upcoming slides. Now, as we see, Kotlin multi-platform is at hype. like for using it for hybrid kind of apps. So that support of coroutines and flows with KM is already available, and even with other Kotlin platform like JS, JVM, etc. So we have support provided already there. Now, this was pretty much about the benefits. Let's talk about some basic implementation. So to create a flow, we need to use a flow builder like flow, flow off, etc. provided by Kotlin to internally create the instance of a flow. We can also use as flow if you want to convert any kind of collections or sequences to a flow. Here we have used this flow off to create a flow. Then we have this emit function to basically send the values to the consumers who are consuming those values. And as we discussed, that because flows are cold, they won't produce values until someone subscribes, or in flow language, I would say until a terminal operator is called. So terminal operators are just suspending functions again that start the collection of the flow. Here you can see we have used this collect, which is used for collecting the values, and it collects values from a flow and executes an action with each item. And we have some other operators also if you want to check like reduce, first, etc. Now I would like to call Himanshu to discuss more about the flow architecture, internals, migration from Rx to flow, and much more. So over to you, Himanshu.
Thank you, Niharika. That was pretty much to grasp everything, like the basics and even the coroutines, right? So Niharika gave a basic introduction how coroutines works and how suspend functions work, right? We also got a very basic idea that how flow works, right? And how we build a flow in a very generic way, correct? Now, since a lot of good apps right now have been built using RxJava, right? And let's say that when you need to migrate something of your code to Kotlin, why not start migrating your RxJava code to flow as well? Or let's say just coroutines, anything. But if you're migrating Rx to Kotlin, right, and coroutines and flow, you need to have both the operators working together. So this is this basic example how we are emitting 1, 2, 3 from an observable, right? This is an Rx snippet. And the same thing which we have is flow of 1, 2, 3 and dot collect. So Niharika showed one of the ways to build a flow, that was flow as a lambda. This is another way to build it. It's flow of, and inside collect, what we are going to get it's 1, 2, and 3, right? So you basically got a very basic and a generic idea how coroutine suspend works internally, right? But there's a new way and a new learning where we have to introduce Kotlin Flow internals as well. So this is one of my favorite topics, how Kotlin Flow actually works. So if you remember in the Kotlin coroutines, there were a couple of options coming up. We used to decompile it on a JVM part. Then there was a continuation callback, which had resume context. And apart from that, we also had two extension functions. We had resume and we had resume with exception. So one was for a success callback, one was for any error, correct? Kotlin Flow is pretty simple, as I have to say this. So this is an interface of flow, right? Which is a generic type. Notice here that you have a collect suspend function, correct? And inside that you have another something called, let's not introduce this as of yet. This is something called flow collector. So first we have a function which is already suspended. It's called collect. And just to see what we have as a flow collector, it's another interface. And that function has emit. So if I go to my previous slide, this one, so it's basically an interface flow, which has a suspend function called collect, which also has another interface called flow collector, right? And flow collector has a suspend function again called emit. So basically, when you have to think of flow on a very generic way, or a very on top of your mind, you just have to think Kotlin Flow as two things. It just emits and it just collects a value. That's it. That's pretty much what Kotlin Flow does. And when you use Kotlin Flow, it is so binded in together with Kotlin coroutines that if you see both the functions here, emit and collect, right? Both are suspend functions here. So it actually works in the conjecture with coroutines itself, and you can't use any of the flow operators or any other stuff without using it with the coroutine, right? So let's understand, if you have, let's say, a legacy code of Rx, let's say RxJava 1 or 2, let's consider for now it's 2, and we want to convert it to a certain newest set of code with coroutines and flow. Just a suggestion, I am showing this, but that doesn't mean that you have to migrate it. Just like a learning which I got from my end is, if your code is working fine, don't just migrate it because it's very fancy. Just first check if there is an actual need to migrate something from Rx to Flow or not, right? So first, let's see what we have. So let's say that I have to do an API call where I have to fetch a list of people, correct? So I have my username, I have my endpoint API v2 user search. I have a certain query which I have to pass on, right? But if you see that we have an observable, which like as a return type, right? So that's pretty much, if you have to understand that this is a return type of an Rx type, right? Now I am going to migrate this into a flow callback or a flow return, right? So to make that, you first need to remove your observable, and you need to add the suspend keyword here. That's it. Like, you don't have to do much other stuff. And next, let's say that we use repository pattern, right? So first we have a repository where we have a function like this, fetch people, which takes page and the query, and it returns of a type flow. So if you remember, in this code, we had a response of list of users, right? But here in the repository, we have something called flow of response of list of users. So basically, when we are going to implement this, we are going to actually return the flow of that whole specific data. So when we work in repository, there was a recommended way that you should not use live data in the repository patterns, correct? So that is where flow comes into the picture, and it binds it very perfectly. So if you have to do, let's say, a DB transaction in the DAO, or let's say you have a repository, right? So you don't have to use live data there as a return type, rather use flow, and this is it. Now, when we have that same thing in a repository implementation, we return something of observables, right? Like how we have it right now. And the user API, let's say if we are injecting it via the constructor, or let's say not even injecting it, on a very basic term, if you are passing it via the constructor, right? The API service, let's call it user API. I'll just call user API.fetch people, and I'll pass on the parameters, right? That's how this would work. But in the terms of flow, you would not just return user API.fetch people, rather we'll actually build up a flow. Now here you can see we are returning a flow builder here. Inside that flow builder, we are actually emitting user API.fetch people, and we are flowing it on dispatcher.io. So basically it's running on the IO thread and it's emitting here. So let's break this down in a very generic way. First, as a first step, we built a flow which we have to return, right? Then we are emitting on the next step, where we are emitting the user API, which we are using in the observable. But now here we have created a suspend function, which is the fetch people. And at the last, I'm running it on the IO thread. And that's pretty much it. Now, as a next step, what we need to do is we need to go to the view model, and we are also passing that helper or the repository in the constructor, right? So now we need to do that fetch people API call. So as part of the KTX library of Android, we have something, a coroutine scope called as view model scope. So it's an extension function which is specifically used for Kotlin view models, Android view models. And this we are going to launch. And since it's a suspend function, and if you remember from our previous talk, it says that to run a suspend function, you actually need a scope. So that specific scope here is the view model scope which we are using. So inside that, we are going to call fetch people, and we are going to pass whatever parameters and the queries we need. right? So this was the first scoping mechanism which we used. Then we do that API call, fetch people. Now let's say if we get some error, some throwables, right? So that comes inside that catch, and here we'll get a throwable. When we get a throwable here, we can use it to respond or to just show the error message to the user. Now inside that collect, what we'll basically do is we'll get that successful response as a lambda, and then you are going to use that successful response. You can pass it to the activity or the fragment, let's say via a live data or a mutable state flow or a state flow, right? So now you can see when we built this part, right, where we are using the flow emission builder, we don't technically do that. We actually create a wrapper to do an API call, and inside that wrapper, we just pass on our API service calls, right? So that's one of the aspects how you can convert an RxJava API call using coroutines and flow. Now let's say we have a library, a very famous library on GitHub called Rx bindings, where everything is converted into the RxJava mechanism, right? So now let's say that if you have to convert something into a flow, for example, you can actually convert a click listener as a flow as well. But let's see a very basic example here. When you actually do add text change listener, right, we actually use it a lot. When let's say that a user is entering some sort of a text coming up in the edit fields, we do a lot of things like that, right? But in my case, what I need to actually do is I need to convert that whole thing as a flow. So to convert it, we use the callback extension or callback lambda, callback flow, which would help us to convert the code, convert the callback as a flow. So inside this, we do all the calls of add text change listeners, and we do the inputs. So basically, in a generic set, what we do is we always need the code which is coming from on text changed, basically whatever new text is being entered, right? So we use this offer, which actually in a sense means we are emitting that results. So here in this case, it's p0.to string. So basically we are offering the string sequence which we are entering to the edit field. And after that, when we have done that offering and it's done and it's converted from the callbacks, we basically close it. So to close it, we use await close. So that's how you can actually convert RxJava to a Kotlin coroutines and a flow code, as well as if you want to use flow in your project, how you can use it. So now we are going to learn as a flow as a data holder, and this is something which Niharika would be taking you forward. So over to you, Niharika.
Yes. If you remember, we have been using live data for all the data updates, and that to the latest value itself. So live data acts as a observable data holder and of course lifecycle aware. But with live data, there are some shortcomings as it is bound with Android platform, and if we have to use it in repository, or I would say some data layer, or also the domain layer, which ideally should be a platform independent thing, or just a pure Java, it should be a pure Java or Kotlin module. So it's something we should avoid. And if you ever get a chance to see how live data transformations work, so whenever we call any map like operator, so with this live data, so what happens is the lambda which we called in the main thread itself. So if you ever get a chance to see the internal code, you can check that. So it shouldn't happen, right? We never told it to switch to the main thread. And if, as I told you that if you look at the internal code, it takes the live data source and adds it to a mediator live data. So now again, this live data has now become an observer for the new values to perform a map function over them. And if you look at the documentation itself, it says that live data observers are always called on the main thread. And if there is some heavy competition we are doing here, then you can imagine the performance compromise. So this is how the transformation for a map operator are written with it. So what alternative can we use? And even when we are already leveraging this Kotlin coroutines and flow, is there anything which can be used as an alternative, or so you just need to learn the concept of this coroutine, or you don't need to learn some new concept for any new component, library, or a framework? So, but with the default Kotlin flow, we can't achieve this because flow is stateless. It doesn't contain anything, something like dot value, and it also doesn't know anything about Android lifecycle. And it doesn't provide kind of automatic posing or resuming of collectors upon any Android lifecycle state changes happening. And of course, it is also cold. So Flow introduced other APIs to optimally emit these state updates and emit the values to multiple consumers as well. And one of those APIs is State Flow. It's a state holder observable flow that emits the current and new state updates to all of the collectors. Now, like live data, we can also have a dot value kind of thing introduced with Flow in this API, the State Flow, and now with this, the flow is stateful in this case. So let's look how it works. You may find many similarities here with live data. Like we were creating a mutable live data for doing any kind of manipulation or mutating or changing any values. We have mutable state flow, with which we can set values to the flow. Then you can see like whenever we have to pass anything to our live data itself, to the view itself, we won't be exposing any kind of mutable live data, so that and to avoid any kind of side effects, we will be exposing the state flow to a UI layer so that our value hampering is prevented. So we should always be exposing this live data only. Now, whenever we set value like this, the consumer who is consuming this value will be consuming it using the collect operator. It will get the value with this collect every time there's a change in the state. So working is pretty much like the normal flow itself, like collecting the values, but now it is like listening for the updates and updating the UI itself. So inside what happens is, this value in the buffer is always the latest value sent to it, and the values that were received by someone won't get lost. So state flow works on a concept of, so it also has this distinct until change kind of thing already implemented. So, and it will always return you this updated value as it filter out the same, and also it filters out the same value. And also one more thing to add here. So state can have more than one, we can now use more than one collector, and it can emit the value to all of them. So state flow becomes active as soon as we create it, and they are hot in nature. We can access the state flow's value without even performing collection. And state flow is always active and memory, and it becomes available for garbage collection only when there are no other references for it before the garbage collection. So this is in brief about the state flow. And now to conclude the talk here, you see that how RxJava we can leverage we had the advantages from RxJava, and how coroutines and flow are helping out here with easy flow. Then of course this coroutines and flow supports Kotlin multi-platform as it's a kind of future thing now. Then we have so as we saw, we talked about the threads and coroutines itself. So threads just takes kind of just taking size in bytes itself. And if I talk about the threads, it is taking kind of a 1 MB size itself. So it doesn't impact the size of the app much. And yes, go with the flow, as you can now see the advantage it is providing to us. And thank you for listening to this talk. And also we tried to keep it like we always wanted to have a talk like we want to listen, like having all the kind of things covered, from the basic how coroutines is helping out with asynchronous approach, and how is it easier to use in terms of if we have to compare with Rx, and then how flow comes into the picture. So I hope we hope that we justify it to this talk. So thank you.
And thank you everyone for having us here. Let's see whatever questions you have, we can answer you right here. And if not, you can connect to our Twitter handles as well to ask any questions if you can. Thank you. So starting off with the questions, I'll start from below. So there's a question, what about different Rx operators like debounce, etc.? Can we do them with the flow? So yes, there are a lot of operators which are present in the flow, which you can use alongside it. So yes, debounce I have used for implementing a search query result in flow, and you can use it.
And also one thing to add here, so we always, whenever we are having this kind of search kind of functionality or autocomplete, so we use this distinct until change. So even with stage flow kind of thing, you will find it automatically added up there. So you don't even, I think you don't need to even add it. You may find some kind of lint warnings suggesting you that it is already handled. So yes. Then we have this can we use custom? So can we use custom thread pools in coroutines? If yes, how? I think you can use it. There is some kind of new, you have this new fixed thread pool context kind of thing, and you can pass a fixed set of threads to be used for your coroutines. So you can use it there.
What is, like, next question is, what is the suspend key? What is the suspend keyword, and what it? Just a sec, I missed it out. And what it is used for beside login. So basically, if you want to execute anything inside a scope or any coroutine, you definitely need to convert that in a suspend keyword. So basically, any task which you think might take time should be executed along with the suspend keyword if something has to be executed inside a coroutine scope.
Yes. Then I have read that starting up coroutines for the first time is much more expensive and can affect app performance. Any thoughts on that? I haven't seen a kind of benchmark like this. I have seen it in an opposite way, like it's a kind of faster kind of thing. And even if I compare to any other thread kind of stuff, like if I have implemented something in with threads itself, and if we call coroutines as lightweight threads, then I would say it is taking much lesser time there. So I don't think that it is taking much time, even on the start itself. So maybe a thread kind of thing is there, but I don't think like that.
So there's another question. What's the key difference in callback flow and channel flow? So considering this, like, callbacks are often used for converting callbacks to a flow. Channel is more of a sequential executions which you have to do. So if you have to consider that, you can think it as of that way.
Will there be a new thread pool per coroutine scope? I would say for one function and calling for the inside function, I think there is only one thread pool, and even only a thread itself can manage multiple coroutines. So I don't think for that kind of block there will be a new different thread pool for different again different classes and different functions there. There can be, but even a single thread can handle different coroutines itself, multiple coroutines itself. So I don't think this is optimized. There should be a kind of just from a thread pool itself, there are even a single thread managing multiple coroutines at a time.
Okay, there's another question saying, is having live data on a repository layer a bad coding practice while using MVVM? It is like a way which has been mentioned by a lot of devs around, that you should not use live data outside of your view model. So basically it works with the view in the conjecture. So you should not be using live data, let's say with your DB layer, or let's say your repository layer. That is why Flow is very smoothen out that process of using a flow there and just passing on the data to the view or the fragment of the activity via live data.
Next question we have: how to debug asynchronous code written using coroutines? I would say yes, debugging asynchronous code is difficult, but what you can do is you can use the blocking kind of functions, or like run blocking, or even you can write tests, but you can have run blocking or async, and then kind of some kind of what I do when I am debugging kind of coroutine kind of work, putting that code, the same code in the run blocking or async, or having some kind of logs there added. So you can try like that.
Okay, so another question is, anything special we have to do for Android data binding? I think with Android Studio, the new Canary build, they have started supporting Stateflow with data binding. So I don't think anything special you have to do, but I'm not pretty sure, but they have started supporting with the Canary build. So it might take time to be stable, yes, but they have started supporting it.
Is coroutine same thing as thread pool? No, it uses thread pool, and then again, even if it is not like a single thread itself, it's a kind of special kind of version of thread itself, like we say the lightweight threads. But it is not similar a kind of thread pool. It uses a mechanism that is thread pool inside it to manage all kind of coroutines itself. So yeah.
Right. Does Flow provide alternatives for single completable maybe? So basically, when you use coroutines and Flow together, you can actually replicate the whole execution flow of single completable and all of that in this execution. But individually, Flow doesn't support it. Flow has to work with coroutines to do it.
Okay. What is the difference between flow and live data? Why not use live data in repository and in room DAO? So as we answered one thing that why to have kind of Android dependencies again in a pure Java or Kotlin module? If you're writing kind of, why we prefer architecture just to separate all the business logic and kind of frameworks or dependencies, or the Android framework itself. So you shouldn't have these kind of stuff in your domain layer or data layer, this repository itself. And for flow and live data, so as we talked about some of the things which we can't have with, so it's not exactly a difference between flow and live data, it's a difference between state flow and live data. So flow is just like again the code, and you can't just have a stream listener kind of stuff. With state flow you can have, and as we talked about the live data disadvantage is like if you are using kind of map kind of functions with it, you may be doing some kind of operations on the main thread itself, and even if you are not switching any kind of thread there. So these kind of, there are even more limitations to it, more shortcomings here. So that way, state flow will work in much performant way. So yeah, we will be using state flow there.
So another question is, could you provide a reference project? So you can definitely check out a lot of GitHub projects there are. Like you can actually see how to use Flow, and even on Kotlin GitHub's profile, you can see a good projects and good references out there.
Yeah. How do you ensure that a mutable state flow stored in a view model restore its current value correctly after process death? After process death, so it is not related to, I think, view the state flow or anything here. Uh, we have provided some kind of now state handle kind of thing with view model, which can handle the configuration changes as well as the process depth. So whatever inside we are using there, we can save and restore the values using state handle. If I am taking this question in a correct, if I am understanding the question in that form which you have written, so you can, so it's like related to the view model itself. View model can have this state handle kind of thing, and you can restore the values from any, if you're, even if you are using live data, you can restore the live data value. The same way you can restore mutable state flow.
Okay. Another question I see is, can we send data in batches using coroutines and flow? I don't exactly understand what you mean by send data in batches, but you can actually execute a certain chunk of data using Kotlin, in fact, to send data there. So if that's what you were asking, I'm not sure with the question here.
Why do we want fetch people to return flow instead of being a single suspend function? So this is why flow was introduced because suspend can have just a single shot of operations. Like I just wanted to do a login kind of operation, so I can use coroutines, this one shot operations with using suspend function. But if you are listening for like fetch people, I am just fetching it again and again for reactive streams, like you have kind of pagination kind of stuff, or maybe there is a kind of list or maybe user details coming up, a list of users, again you're scrolling your screen, so these kind of stuff, if it is there, it's a kind of reactive stream, so that can't be handled through suspend function. You have to use flow there.
Right. The other is, can we use Dagger to a coin with stateflow and coroutines? I don't understand again this question, but yes, you can actually use Dagger to, or let's say any dependency injection framework when you're using coroutines in your project. So if that answers your question.
Yeah, I have used coin with coroutines, so you can use any dependency injection with it. I think it isn't any kind of dependency injection framework is not related to stuff I'm using with it. It's a kind of, again, architectural level thing, so you can use any kind of stuff there. What is does Flow provide alternative for single, completable, and maybe in Rx? So these are already handled through suspend coroutines. If I talk about the single, completable, and maybe. The part which we had to do for reactive streams, the observable and flowable, that is getting handled through flow. So it's about coroutines plus flow. So half of the part is already handled through coroutines. The single, maybe, and completable kind of same work you can have through the suspend functions, and all kind of observable kind of events you can do through this flow.
Okay, another question, and maybe this is the last question because we are running out of time. So how is error handling in Flow? Like, does it have something like an exception handlers? So basically, if you get any sort of an error, apart from your response error, like when you get something from your backend, so first error, everything can be caught inside that catch block. So that catch block returns a throwable, and any type of specific error which comes up, you can get there. And let's say if you're managing a response in a state of, let's say, response I results or anything, you can use that inside your collect. And let's say if that query parameters were not successful and some error were thrown, you can get that in that specific set. So majority, the catch block is responsible for handling your exceptions here. I think maybe if we can actually use other questions on our table, because we are actually running out of time. Thank you so much, everyone. Thank you so much for asking a lot of questions, and I would be around, me and Niharika, so you guys can ask any questions and directly there.
Yes. Thank you.
Yeah, thank you so much, Himanshu and Niharika.